The pressure on your body would be over 1,100 times greater than at sea level. Imagine 50 jumbo jets, fully loaded, stacked one on top of the other, directly on your chest. You wouldn't last a fraction of a second. This is Challenger Deep, the lowest point on Earth. You are sinking into the Mariana Trench. First, the light goes. It fades from blue to a deeper indigo to a permanent midnight that begins just 1,000 meters down. You still have 10,000 meters to go. The temperature plummets to just above freezing, a constant 2 degrees Celsius that leaches heat from any machine or any body. The silence is absolute, a heavy, weighted nothingness. Every law of surface biology says this place should be a sterile desert, a void. Pressure like this doesn't just crush, it fundamentally changes chemistry. It should prevent the complex proteins of life from ever folding correctly. It should solidify cell membranes. In theory, life here is impossible. And yet, down here, in the crushing dark, something moves. Look closer. That delicate flower-like structure on the sea floor. It's called a xenophyophore. It's a single cell, the size of your fist. It builds its own intricate skeleton from the sediment, surviving in a world that should kill it instantly. And it's not alone. You see swarms of amphipods like ghostly shrimp navigating the abyss. They feed on the marine snow, scraps of organic matter that can take over a year to fall from the sunlit world above. A constant rain of death that fuels an impossible ecosystem. Think about what that means. Their entire world is built on the ghosts of another. But here is the part that keeps scientists awake at night. The pressure isn't just a physical force, it's a chemical weapon. At this depth, it attacks the very molecules of life, warping DNA and shredding the delicate machinery inside every cell. So, if the blocks of life themselves should be disintegrating, what is holding these creatures together? The year is 1960. You are sealed inside a cramped steel sphere just under 7 feet wide. The walls are 5 inches thick. Outside your tiny quartz window is absolute blackness. You are descending. Fast. This is the Bathyscaphe Trieste, and your target is the deepest point on Earth. On board are 2 men, Swiss oceanographer Jacques Picard and U.S. Navy Lieutenant Don Walsh. Their mission was considered by many to be a suicide run. For 5 hours, they fell through the water column. The temperature dropped to just a few degrees above freezing. The pressure built with every meter, 1,000 pounds per square inch, then 5,000, then 10. They were entering a place more hostile than the surface of the moon. And then, a loud crack echoed through the hull. A hairline fracture had appeared in the outer pane of the entrance tunnel window. They were 7 miles down. A catastrophic failure now would not mean drowning. It would mean instantaneous, total obliteration. They chose to continue. When they finally touched the bottom, at 10,911 meters, the pressure outside was nearly 16,000 pounds per square inch. Imagine the weight of 50 jumbo jets stacked on your body. That is the force trying to crush you. They peered out into the silt, illuminated by their single floodlight, and they saw something. A flatfish, something like a soul, swimming calmly away. Life? Here, it was a monumental discovery. But for decades, their sighting was dismissed. Biologists argued it was impossible for a vertebrate to survive such pressures. They said Picard and Walsh must have been mistaken. And so, for 50 years, the official story was that the deepest ocean was lifeless. But here's the part nobody talks about. They were right all along. But how? How does biology itself bend its own rules to survive in a place that should be sterile? The pressure you feel at the bottom of the Mariana Trench is over 1,000 times greater than at the surface. This force doesn't just crush, it chemically attacks life. It squeezes water molecules so tightly into the machinery of your cells that proteins, the blocks of life, unravel like cheap sweaters. Enzymes stop working. Cell membranes turn to solid wax. By all the laws of biology you learn in school, complex life should simply fall apart. It should be impossible. And yet it isn't. Deep-sea organisms have evolved a secret weapon, a suite of remarkable organic molecules called piezolites. Think of them as molecular scaffolding. They surround the proteins, protecting them from the crushing force of the water, allowing them to keep their shape and function. They literally hold life together against impossible odds. It's a stunning feat of evolution, one that allows the Mariana snailfish, a creature with a gelatinous body and a partially formed skull, to be the deepest living fish on the planet. It thrives at 8,000 meters, but solving the pressure problem only creates another. Where do you get the energy? There is no sunlight. No plants. The abyss is a food desert. Most of the life down here survives on a constant drizzle of organic matter from above. It's called marine snow. Dead plankton, fish scales, fecal matter. It can take months for a single flake to reach the bottom. It's like trying to live on one crumb of bread a day. The creatures here are masters of patience. Giant amphipods, crustaceans the size of rats, act as tireless scavengers, sniffing out any morsel that lands. Strange, single-celled organisms called xenophyophories build intricate shells from sediment, farming bacteria on their surface. Life here it's patient, it's built on scarcity. That was the accepted theory for decades. The deep was a quiet, starved place. But recent discoveries have turned that idea completely on its head. Scientists analyzing the tissues of those deep-sea amphipods found something shocking. Carbon-14, specifically a type of carbon-14 that could only have come from one source. The atmospheric nuclear bomb tests of the 1950s and 60s. You are 8,000 meters down. The pressure here is 800 times greater than at the surface. It's the equivalent of 50 jumbo jets stacked on top of you. Nothing with bones should be able to exist here. And yet, something moves. It's pale, ghostly, almost translucent, its organs visible through its skin. This is Pseudoliparus swirri, the Mariana snailfish, the deepest fish ever recorded. It has no scales. Its bones are soft, flexible cartilage. Its skull isn't even fully closed to prevent it from being shattered. At the surface, its cells would literally burst from the lack of pressure. So how does it hold itself together in this crushing abyss? The answer is a chemical trick, a molecule called trimethylamine N-oxide, or TMAO. It floods its cells with this compound, creating a perfect internal counterpressure that stops its proteins from being squeezed into useless shapes. This creature doesn't just tolerate the pressure, it requires it to live. This is not survival. This is absolute mastery of an impossible environment. But the snailfish isn't alone. Look closer. Scuttling across the seafloor are crustaceans, amphipods. They are distant relatives of the tiny shrimp you might see at the beach. Except these are not tiny. Some grow up to 30 centimeters long, giants of the deep. For decades, we saw this place as a sanctuary, the last truly pristine wilderness on Earth. Untouched, unspoiled, a beautiful, simple story. And here's where that story completely falls apart. In 2017, a team from Newcastle University, led by Dr. Alan Jameson, sent unmanned landers into the trench. They weren't just looking for new species, they were looking for our signature. They brought amphipods back to the surface and carefully analyzed their tissues. What they found should stop you cold. They found PCBs, polychlorinated biphenyls, a man-made industrial coolant, banned worldwide since the 1970s because of its extreme toxicity. They also found PBDEs, chemical flame retardants used in plastics and electronics. These are not natural compounds. We made them. And they are now inside the bodies of creatures living at the deepest, most remote point on our planet. But wait, that's not all. The concentration was not some trace amount. It was staggering. The levels of PCB contamination in these Mariana Trench amphipods were up to 50 times higher than in crabs from the Liaohe River, one of the most polluted rivers in all of China. Think about what that means. The most remote spot on Earth is more contaminated with certain chemicals than a heavily industrialized waterway. How is this even possible? The trench is not isolated. It's the planet's final drain. For a century, we dumped our industrial waste and our plastics into the oceans. These materials break down. They attach to dead plankton and other organic matter. And then everything sinks. This constant, gentle rain of death and debris is called marine snow. And it carries our chemical legacy down, kilometer by kilometer, for 11,000 meters. The unique V-shape of the trench acts like a funnel. It concentrates the filth of an entire civilization into its narrowest point. Every plastic bottle that found its way to the Pacific, every industrial spill, a part of it is ending up right here. And here's the part nobody wants to talk about. The very biology that allows these creatures to thrive in the deep may be what's killing them. Remember the gigantism? The metabolism caused by the cold and pressure? It means they live for a very long time. And as they eat the falling marine snow, they accumulate these toxins in their fatty tissues over their entire lives. They can't get rid of it. They just collect it. The same adaptation that let them conquer the pressure makes them a perfect sponge for our poisons. We have reached a place we can barely visit, and managed to poison it before we even truly understood it. The creature built to withstand the weight of an ocean may not survive the weight of humanity. Imagine the feeling. You are falling for hours through a column of black water. The temperature drops to near freezing. The pressure outside builds, ton by ton, on your tiny sphere of protection. A pressure so immense it could crush a military submarine like a paper cup. 1,600 times the pressure you feel on your skin right now. This isn't a thought experiment. This is the journey. And you are the passenger. In 1960, Don Walsh and Jacques Picard were the first to make it. Inside a steel ball 7 inches thick, they touched the bottom of the world. They had a single, tiny porthole made of plexiglass. For 20 minutes, they stared out into the crushing black. And something stared back. They reported seeing a creature. A flatfish, they said, about a foot long, swimming calmly away. A living thing with eyes. I'm in a place biology insisted should be a dead zone, proof of life. But here's the part that gets complicated. Many modern biologists argue that a vertebrate fish like that simply cannot survive the calcium-crushing pressures of the Challenger Deep. Their bones would dissolve. So, what did Walsh and Picard actually see? Was it a sea cucumber? A trick of the light on the swirling sediment their craft kicked up? Or was it something else entirely? The first mystery from the deep. For 52 years, no human returned. Then came one man, a filmmaker obsessed with the ocean, James Cameron. He didn't just want to touch the bottom. He wanted to stay, to film it, to see it with his own eyes. His submersible, the Deep Sea Challenger, was a vertical torpedo designed for a solo pilot. For 7 hours, he was arguably the most isolated human being in history, more alone than any astronaut orbiting above. He described the bottom not as a monster's lair, but as a desert, lunar, serene. He turned on his lights, and the void came alive, not with monsters, but with swarms of tiny creatures called amphipods. They looked like shrimp, but they were giants of their kind, drawn to the strange visitor from another world. Think about what that feels like. The sound of the submersible groaning around you, the hull compressing under the weight of an entire ocean. Every creak, every pop is a reminder of the violent death that waits just inches away. You look out your tiny window. You see the beam of your light cutting a perfect cone into a darkness so complete it feels solid. This is not just the absence of light, it feels like a presence. And in that presence, there are other eyes. The Mariana snailfish. It looks like a ghost, a translucent, scaleless creature with a head like a cartoon skull. It doesn't just survive here, it thrives. It is the apex predator in a world built on impossible physics. Its secret? It has no air-filled spaces in its body. Its bones are flexible cartilage. Its cells are filled with special molecules that protect them from being squeezed to death. It is a masterpiece of adaptation, a quiet testament to life's refusal to surrender. For decades, we saw this place as the last pristine wilderness on Earth, untouched, unseen, a perfect clean slate. When explorer Victor Vescovo made his record-breaking dives in 2019, he discovered 4 new species, 4 new miracles of evolution. But he also found something else, something horribly familiar. Lying on the silt, 10,928 meters down, was a plastic bag and a candy wrapper. Let that sink in. We sent our garbage to the deepest, most remote corner of the planet before we had even met its inhabitants. The eyes in the dark have been watching us arrive. What have we shown them about who we are? You ascend. For hours, 11,000 meters of waterly recede above you, the crushing weight lifting, molecule by molecule. The absolute black gives way to a faint, ghostly blue. Then a brighter blue. You break the surface and the sun hits your face for the first time in a day. You feel like you have returned from another world, because you have. But here's the part nobody wants to admit. You did not leave that world untouched. In 2019, explorer Victor Vescovo piloted his submersible, the Limiting Factor, to the very bottom of the Challenger Deep. He saw ethereal snailfish and strange, stalked creatures. He also saw a plastic bag. Think about that. Our casual floating waste arrived at the deepest point on Earth before we established any permanent presence there. It beat us to the bottom. Worse, a recent study found that nearly every single crustacean tested from the trench had plastic fibers in its stomach. Our signature is already there. And now a new kind of pressure is, not from water, but from ambition. Beneath the silt lie vast deposits of cobalt, nickel, and manganese. The very materials needed for our electric car batteries, our phones, our green future. The International Seabed Authority is already writing the rules for a new gold rush. Companies are drawing up maps, not for exploration, but for extraction. We are planning to industrialize a place we fundamentally do not understand. Over 75% of our own planet's ocean floor remains unmapped in any detail. We know the surface of Mars better than we know the bottom of our sea. This is a library filled with millions of books we have not yet learned to read. And we are considering bulldozing it for the paper. Yet, every new dive reminds us of what's at stake. It reveals creatures that rewrite the rules of biology. Fish with antifreeze proteins in their blood. Microbes that breathe sulfate instead of oxygen. These organisms hold secrets to new medicines, new materials, perhaps even secrets about the origin of life itself. We have always been explorers. Pushing into the unknown seems to be part of our design. But after charting every continent and reaching for the stars, we find the most alien world has been here all along, waiting patiently beneath the waves. So as we stand on the shore of this final frontier with the power to either preserve it or plunder it, what kind of ancestors will we choose to be?